So these are the values of your derivatives. F 0 is 0. So f dash of 0 is 1. F double dash of 0 is minus 1 factorial. F3 at 0 is 2 factorial. F4 at 0 is minus 3 factorial. And in general, Fn at 0 will be minus 1 whole raised to n minus 1 and minus 1 factor. So therefore, log of 1 plus x will be equal to, so first term is 0 plus 1 into x by 1 factorial minus 1 factorial into x square by 2 factorial varum plus 2 factorial x cube by 3 factorial minus 3 factorial into x raised to 4 by 4 factorial etc. The nth term will be minus 1 whole raised to n minus 1 n minus 1 factorial into x power n by n factorial plus etc. So that is going to be equal to you can see that these factorials will cancel off. In the so you'll be getting the first term as x, then here you will get x square by 2, then the next term plus x cube by 3 varum minus x raised to 4 by 4 and plus x raised to 5 by 5. So we'll continue that way. So this can be written as summation n equal to 1 to infinity. So the general term is x power n by n, and when n is 1 it is positive, and odd ആകുമ്പോൾ positive ആണ്, even ആകുമ്പോൾ negative ആണ്. So that is minus 1 raised to n minus 1. So this is the required expansion for log x. And now let us look at one more example. So expand f of x equal to log cos hx. Here f dash of x will be 1 by cos hx into sin hx varum. So that will be equal to tan hx. And next we have f double dash of x. So f double dash of x will be equal to sec square sec x square x varum. And now let us expand the derivatives in another way. So sec h square x normal, that will be 1 minus tan h square x. So this can be written as 1 minus. So this will be equal to your first derivative y1. So this is equal to 1 minus y1 square. So we will get the equation y2 equal to 1 minus y1 square. So for finding y3 will be minus 2y1 into y2. And if you want y4 will be minus 2 y1 y3 plus y2 square varum. Then y5 will be minus 2 y1 y4 plus y2 y3 plus 2y2 y3 varum. So these are going to be the derivatives. Okay. അല്ലെങ്കിൽ നമ്മൾ ഇത് നേരിട്ട് ചെയ്യുമ്പോൾ വീണ്ടും the number of products will increase, കുറച്ചുകൂടി complicated ആവും derivative എടുക്കും. So we can proceed in this manner also. So let us look at what are the values of derivatives. So we will write it here. So f of 0 will be cos h0. Cos hx in the value e raised to x plus e raised to minus x by 2. Upper cos h0 എന്ന് പറയുന്ന 1 വരും. Log of 1 will be equal to 0. Now for y1 at 0 will be tan h0 will be again 0 varum. So y2 will be 1. y3 is 0 varum. y4 minus 2 varum, and y5 is y5 okay, we'll get y1 0 ആകും, y1 ഉം y3 ഉം 0 ആണ്. അപ്പോൾ y5 എല്ലാ ടേംസും 0 ആണ്. അപ്പോൾ നമുക്ക് ആകെ 2 നോൺ സീറോ ടേംസ് മാത്രമേ കിട്ടിയിട്ടുള്ളൂ. സോ ലെറ്റ്സ് ഗോ ഫോർ y6 ഓൾസോ. ഇപ്പോഴും സീരീസ് എഴുതുമ്പോൾ ഒരു 3 ടേം എങ്കിലും എക്സ്പാൻഷനിൽ വരുന്നത് പോലെ ചെയ്യുക. ഓക്കെ, സോ this will be minus 2. So derivative y1 y4 will be y1 y5 plus y2 y4, and this is 3 y2 y3. അപ്പോൾ ഡെറിവേറ്റീവ് എടുക്കുമ്പോൾ y3 square വരും plus y2 y4. So that is y6. So let's look at the value of y6 at 0. y6 ന്റെ വാല്യൂ വരുമ്പോൾ y3 ഉം y1 ഉം വരുന്ന ടേം 0 ആവും. So you will have 4 y2 y4, minus 2 into 4 y2 y4, that is minus 8 into y2 is 1, y4 is minus 2. For minus 2 varum, so the value is going to be equal to 60. So we have got the value of derivatives at the point 0. So therefore log cos hx is equal to, so first term is 0, second term is 0, then the third term, so you get 1 into x square by 2 factorial plus again y3 is 0, then minus 2 x raised to 4 by 4 factorial, y5 is 0, and last term was 16, so 16 x raised to 6 by 6 factorial. So that is x square by 2 minus x raised to 4 by 12 plus x raised to 6 by 45. ഇനി എപ്പോഴും നമുക്ക് സ്റ്റാൻഡേർഡ് ഫോമിൽ കിട്ടണം നിർബന്ധമില്ല, എപ്പോഴും ഒരു ക്ലോസ്ഡ് ഫോമിൽ ഒരു സീരീസിലെ ഫോമിൽ എഴുതാൻ പറ്റുന്ന നിർബന്ധമില്ല. സോ വാട്ട് എവർ ഇറ്റ് ഈസ്, ഫൈൻഡ് at least 3 non-zero terms when you find the series. Okay. And now as an exercise, please find the expansion for and sin x and tan x series containing powers of x. So please solve these.